Analyzers, and welcome to your Chapter 4, Lesson 3 notes video. And we are going to talk all about adding and subtracting radicals today. But of course, before we do, let's simplify yet again, because that's just our jam, is we've got to be able to simplify radicals before we can do anything else, right? Oh, let's see. Okay, we got to simplify these. Oh, this is yesterday's. Right? This is yesterday's lesson where we multiply together first and then we simplify that answer. Okay, so let's see. The stuff under the radicals multiplies together. So 9 times 16 is under the radical, and I get 144 under the radical. And I'm sure you know that 144 is a perfect square. So I have to simplify that, right? So let's see, and that's the next one over, number or letter B as well. So second and radical of 144. What's the square root of 144? 12. So these two things result in the same answer. But wait, I haven't learned anything yet about adding and subtracting radicals. That's what I'm about to learn, right? So what I do know is that 9 is a perfect square and that 16 is a perfect square. So actually, why don't I start by taking their square roots? Okay, so square root of 9 is 3, and the square root of 16 is 4. And what is 3 plus 4? It's 7. Wait a minute, what's 9 plus 16? Let's just check that out. What if I had added their radicands together? I would get 25, right? So what's the square root of 25? It's 5. Wait a minute. These don't match up. Now, these did, because that rule for multiplying worked. Multiplying the radicands together works. It's a thing we're allowed to do, and then we simplify that answer like we were able to do here. You can't just add radicals together. If they're not the same number under the radical, you cannot add or subtract them. So that's our big rule for adding and subtracting radicals, is you have to have the same radicand. Okay? You cannot just add them up under the radical. That doesn't work. So this is more like when you're adding polynomials together and you have to have the same variable in order to add your polynomials up. Okay, so that's actually how I approach it with you, is like radicals and unlike radicals, right? Or radicands, if you will, the number underneath. Okay, so here's some like ones. You know, radical 5 and radical 5 are the same exact radicand. Radical 10x and radical 10x, they are the same exact radicand. Negative 2 radical 17ab and 9 radical 17ab, they are the same exact thing under the radical. Okay, their coefficients are what I will add and subtract. Okay, these are unlike. If they are not exactly the same thing under the radical, you cannot add and subtract them, and that's it. Okay, that is the bottom line with these. So I do start you with some polynomial expressions that are like terms. So we'll kind of remind ourselves, when you have like variables, you can add and subtract their coefficients together. So 2x plus 5x gives me a total of 7x. 9x minus 4x leaves me a total of 5x. 3x minus 7x leaves me with negative 4x. Because their variables were the same, I can add and subtract their coefficients together based on their signs. It goes that way with like radicands as well. As long as their numbers under the radical are the same, their coefficients can add up. So 2 radical 3's plus 5 radical 3's is 7 radical 3's. 9 radical 2's minus 4 radical 2's, same radicand, it's 5 radical 2's, 9 minus 4. 3 radical 10's minus 7 radical 10's, Same radicand, subtract their coefficients. 3 minus 7 is -4 radical 10. Also notice that the radicand did not change. Just the amount I had of them changed. So how many radical 3s I have total changed. How many radical 2s I have total changed. How many radical 10s total I have changed. That's what we're doing here. So you have to have a like number under the radicand for them to actually add and subtract. Okay. If you don't, you just leave them as two completely separate radicals being added up. Okay. So if they don't have the same radical, you can't add their coefficients. So if you have a question like 5 radical 2 plus 4 radical 3, you cannot actually add them up. Your final answer is these radicals added separately like this. Because they are unlike terms, you cannot go any further. You cannot simplify further. That is as simplified as you can get. Okay? Example, example, example. There is my procedure for doing so. If you don't have like radicals right off the bat, try simplifying one of the two. See if you end up with like radicals, and then you can add up their coefficients. So that's what happened in this problem. I have radical 12 plus radical 3. Well, as of right now, radical 12 and radical 3 are not like radicands. But what I do know is radical 12 has a perfect square factor. So I want to bring that perfect square factor out and see what my leftover radicand is. And when I've done that, so I simplify it right here. When I've done that, now I've got like radicands. So now I can add their coefficients up. When you just have a radical 3, it's the same as having 1 radical 3. So 2 radical 3s plus 1 radical 3 is 3 radical 3s. Okay, here we go. Which of these statements is not true? Well, I don't even have to look very far because I immediately catch one of my multiple choices where I'm adding different radicands and they've added under the radical. We saw right in the first box that this is patently untrue. You cannot add the radicals under the radicand. So number 4 is not true. Okay. For exercise 4, number 4 choice, not true. You can multiply numbers together under the radical. So we've done that here. Well, here we simplified. Here we had the same number under the radical, so we were allowed to add up how many we had. So there you go. All the rest are true. Let's do some problems ourselves. And here we go. Add and subtract the following radicals and leave answers in simplest radical form. Okay, so on number 1, which I'll zoom into, I do not have like radicands. Okay, so right now I don't have like radicands on number 1. But if I try to simplify both of them, maybe my leftovers will be like radicands. And it turns out that both 50 and 8 are evenly divisible by perfect squares. So there's some perfect square factors that are still under the radical and they're not allowed to stay. So let me come over here, simplify 50 into perfect square and leftover. The perfect square that divides into 50 is 25. 50 divided by 25 is 2 for my leftover. Square root of 25 is 5 radical 2. So that is what I'm going to use instead of radical 50. Now let's try simplifying radical 8 into perfect square and leftover. Well, the perfect square that divides evenly into 8 is 4. And 8 divided by 4 is 2 as the leftover. And what is the square root of 4? It's 2. Bring that radical leftover. Now look at my radicands. They're the same, so I can add their coefficients or subtract their coefficients. 5 minus 2 is 3 radical 2. That's my final answer. number 2. Okay, as of right now, my radicals do not have the same radicand. So radical 27, radical 12, different radicands. Let's simplify. There's perfect squares under there. Let's see if once we do that, we have like radicands. So remember, this coefficient comes with, but we divide into perfect square and leftover. The perfect square that divides evenly into 27, 9. 27 divided by 9 is 3 is the leftover. Take the square root of 9, you get 3. Multiply your coefficients together. 2 times 3 is 6 radical 3. That's what I'm going to use instead. On the other side, it's a negative 5, right? And we're going to divide into perfect square and leftover. Perfect square that divides evenly into 12 is 4. Leftover is 12 divided by 4 is 3. Like radicands. There we go. Square root of 4 is 2, and negative 5 times 2 is negative 10 radical 3. So now I actually add those or subtract those in this case. And 6 radical 3s minus 10 radical 3s, that leaves me with negative 4 radical 3s. That is how many I have. When you have the same number under the radicand, you can add and subtract the coefficients. When you don't, look to see if you can simplify either or both. In our cases, for both of these, it was both. Then see if you get the leftover as like radicands. See if that happens again here. Exercise 6. Oh, yeah. Okay. Radical 8, we've actually already simplified up here. But it's radical 4, radical 2, right? And what's the square root of 4? 2. So 2 radical 2. And then 18 we haven't done yet today. So perfect square and leftover. The perfect square that divides evenly into 18 is 9. 18 divided by 9 is 2. Take the square root of 9, you get 3 radical 2. So we're adding these up. 2 radical 2s plus 3 radical 2s is 5 radical 2s. And which choice is that? Choice 2. Oh, sorry, a little too zoomed in there. There we go. Okay. Now notice, oops. Oh, that was weird. Notice, it's my choice. Correct choice is 2. What they did wrong here was they just straight added these two things up, and you absolutely cannot do that. Okay? You can multiply 2 radicals that don't have the same number underneath together. You cannot add them together. What did they do wrong there? Oh. No, that's not right either. 4 and 9, that's not right. Didn't take square roots. I don't know what they did wrong there. Anyway. Number 7. I think we've simplified radical 12 today already. So let's do that. So let's see. Yep, above here, we simplified radical 12 into radical 4, radical 3. What's the square root of 4? It is 2. So 2 radical 3. Now, 48 we haven't done yet today. There is this negative in front, so there's negative 1 that's going to come with. So negative and perfect square and leftover. What perfect square divides evenly into 48? There's actually 2 of them, but which one's bigger? Here, I'll just show you real quick. 48 divided by 4 leaves me with 12, but we know that 12 had to simplify. So let's try 48 divided by 9. Nope, that's not working. So let's try the next one. 48 divided by 16. Aha! 16 is the biggest perfect square that divides evenly into 48. And the leftover is 3. Right? And so now we take the square root of 16. Brooke, what is it? I heard her from afar. She said 4. So that means that there's this negative 4 radical 3 when we simplify. So now that's what we're subtracting here. And now that we've got like radicals, we can actually subtract their coefficients. 2 minus 4 is negative 2 radical 3 is my final answer here. And let's see which choice is negative 2 radical 3. Aha, tried to distract me here. Negative 2 radical 3. Tried to distract me. Again, Notice this choice, absolutely untrue. You cannot just subtract 12 and 48 that are the numbers under the radical. You can't do that. You have to simplify first, or you have to have like radicals of your already simplified radicands. Okay? So that is what you are practicing, my fine math analyzing friends. Please let me know if you have any questions about adding and subtracting radical expressions. And otherwise, I'm sure you'll do wonderfully with it. And I shall be seeing you for another session of multiplying, because now that we know how to add and subtract radicals, we can do some of the longer multiplying radical pieces that I didn't do in lesson 2. Okie dokie, guys. I'll be seeing you. Have fun.